Good afternoon and welcome to Chem 151 News. I'm your news anchor, Keisha and Ancheta, here to talk about today's top story. 100 million Americans refuse to take a shower due to fear of surfactants in their products. But first, let's hear from some UCSD students and their thoughts on taking showers.
Thank you, Keisha. I'm here with UCSD student John Johnson to ask a few questions about the latest trend. John, do you take showers?
No, I do not.
And why not?
Because they're putting chemicals in my shampoo and body wash.
What chemicals are you talking about?
Surfactants. They're putting surfactants in my cleaning products and they're making us sick. So personally, I'm not taking any more showers ever again.
Do you know what a surfactant is?
Yeah, it's in our cleaning products. Wake up, America.
No, surfactants are...
Surfactants are amphiphilic molecules and contain two distinct regions, a hydrophilic water-loving head and a hydrophobic water-repelling tail. The hydrophobic head is able to form interactions with polar substances, while the hydrophobic tail can form interactions with the molecules of nonpolar substances. This unique structure allows surfactants to lower the surface tension of water and facilitate the mixing of oil and water-based substances. When surfactants are added to water, they initially spread out, with the hydrophobic tails attempting to avoid contact with the water, and when surfactant concentration exceeds a specific threshold, also called the critical micelle concentration, the molecules will spontaneously assemble into micelles. This means they form spherical structures where the hydrophobic tails cluster inwards while the hydrophobic heads remain exposed on the outside. Micelle formation is fundamental to emulsification, which is how detergents and soaps break down grease and oil.
We use surfactants every day. It is in our shampoo, body wash, toothpaste, detergent. You get the point. So how can they harm us when they make everything nice and clean? John might not be wrong though. Surfactants might be harmful to the environment and us. Many cleaning products that we use daily have synthetic surfactants in them. Synthetic surfactants are generally more harsh and drying for our skin as compared to biosurfactants because they usually strip away more of our skin's natural oils and interact more with the proteins on our skin. Synthetic surfactants are usually less biodegradable than their natural counterparts. The buildup of surfactants pollutes water and threatens plants and aquatic life. High levels of surfactants in water can cause surfactants to enter organs of aquatic animals. One popular group of surfactants used in cleaning products are alkyl phenolethoxylates, or APEs. They are mainly found in industrial laundry detergent and lawn care products. Alkyl phenolethoxylates function as an endocrine disruptor, affecting both genders, potentially causing reproductive complications. Alkyl phenolethoxylates has been associated with breast cancer as well as exacerbating metastatic cancer. Fortunately, some countries like Switzerland and European Union have banned the use of alkyl phenolethoxylate. Other countries like Japan and Canada has restrictions for this surfactant. The US does not have a federal ban on APEs. However, some states like California and Washington have started implementing restrictions. Biosurfactants are a great alternative since they are more biodegradable and have lower toxicity. So don't lose hope on showering.
There are four main types of surfactants: anionic, cationic, non-ionic, and amphoteric. Anionic surfactants have a negatively charged hydrophilic group. The negative charge helps molecules lift and attack soils and micelles. An example brand that uses anionic surfactants is Dawn dish soap. The surfactants in Dawn dish soap are sodium lauryl sulfate, C1016 alkyl dimethylamine oxide, and D-Seth8 and C911 Pareth8. Cationic surfactants have a positively charged hydrophilic group. This makes them good for anti-static products and antibacterial products. An example brand that uses cationic surfactants are Clorox wipes. The surfactant in Clorox wipes is alkyl dimethylbenzyl ammonium chloride. Look at how it gets the stains out of the counter. Wow. Non-ionic surfactants have a neutral hydrophilic group, meaning that they don't have a charge. This makes them good for emulsifying oils. Non-ionic and anionic surfactants are usually paired up together to make really good multi-purpose cleaners, like Mr. Clean.
The surfactants in Mr. Clean Freak Multi-Purpose Cleaner are C1016 alkyl-dimethylamine oxide and PEG PPG ethyl hexyl ether. Wow, clean free.
Amphoteric surfactants have a both negative and positively charged hydrophilic group. This makes them pH balanced. So in acidic solutions, they behave like cationic surfactants, but in alkaline solutions, they behave like anionic surfactants. An example of them are their use in body washes like Dove body wash.
The surfactant in Dove body wash is cocamidopropyl butane. Look at all that foaming action. Gorgeous.
Like my peers said before, surfactants are molecules that have both hydrophobic and hydrophilic parts, creating a stable interface. This composition allows surfactants to organize themselves into a variety of different structures when they are placed in the appropriate environments. This process is called self-assembly. Self-assembly is commonly seen in emulsions, foams, and liquid crystal systems, in which surfactants spontaneously form organized structures that respond to pH, temperature, and concentration. There are three primary types of surfactant phases in self-assembly. The first that I will be discussing today is hexagonal. Hexagonal is a liquid crystalline structure, and in this phase, long cylindrical micelles, which are made up of these spherical micelles, which are made up of surfactant molecules, and these long cylindrical micelles arrange themselves into a tightly packed, surprise, surprise, hexagonal pattern. So how does this happen? The spherical micelles align parallel with one another, and this creates a water phase between the molecules. This phase typically occurs when the surfactant molecules have a relatively balanced hydrophilic-hydrophobic character. The second phase of surfactant self-assembly that I will be discussing today is the lamellar phase. And in this phase, the surfactant molecules arrange themselves into flat sheet bilayers. This is what gives it its sandwich-like structure. Lamellar phases are a type of lyotropic liquid crystal, which means they have fluid-like behavior within each layer while maintaining a long-range ordered structure. This phase typically occurs at higher surfactant temperatures and concentrations compared to the micellar phases. The third phase that I will be discussing is the cubical phase. In this phase, surfactants arrange themselves into a complex 3D structure, as pictured here, of micelles forming a three-dimensional cubical lattice. This creates a continuous network throughout the solution where aqueous phases fill the space in between each micelle. However, the type of cubic assembly depends on the surfactant molecule and concentration. The two types of cubic structures are as follows. The first is the discontinuous phase. With this, the micelles are discrete spheres embedded in a continuous aqueous phase. This is the most common type. The second phase, which I cannot draw, but will insert a picture of here, is the bicontinuous cubic phase. Now, this phase is a little bit more complex, where the aqueous and hydrophobic areas form continuous interconnected networks that resemble sort of a sponge-like structure.
And that's all for today. I'm Keisha and Ancheta, reminding you to take a shower and to wash your hands with soap and to take a shower with soap and to wash your hair.